Viper chemistry students. Let's talk about polyionic compounds. So, up to this point, with our studies on compounds in Unit 5, we've been kind of basically focusing on binary ionic compounds. Now, what that entails, binary means two. And so, we've seen compounds like sodium chloride or calcium fluoride, for example, or something like that. But there's also what are known as polyatomic ions. So let's take a look at that and how that works. As we learn how to write formulas for ionic compounds and also naming, so there are some things here that we need to, bring to your attention here. So what I mean by that is that some of these have more than one atom, and the prefix poly means many. Okay, so let's kind of see what that refers to here. So you can see that polyatomic ions refer to ions that consist of two or more atoms that act as a single ion. Okay, so here are some examples here. So for example, potassium hydroxide here is KOH. Now, potassium is represented with the element symbol K. Remember, that's an alkali metal. But OH is an anion that is a polyatomic anion. Now, it's also referred to as an oxyanion because it has oxygen in it. It has a -1 charge. Now, there's a reference table that I have been posting in your resource module, which is, on Canvas. And also at the beginning of week 16, you should see a link to a reference table. And it will have some of these polyatomic anions there so that you can see what their charges are. But since potassium K is a +1, and it's an alkali metal, and always a +1 ion, then OH must be a -1, and that would be correct. It is. Now, this next one here, silver sulfate, silver is always a +1. And so, since there's two of them, then sulfate here, SO4, is a polyatomic oxyanion with a negative charge of -2. Okay, so that's why it fits directly together. Now, notice that the naming's a little bit different. Like, okay, this is hydroxide, okay, OH is, whereas SO4 is sulfate. So you're going to see some naming like that, and really, as chemistry students, we just kind of have to get some practice with it and just kind of learn, what the names are. So that reference chart, at our Google Meet Wednesday, I will kind of refer to that reference chart. We'll look that over during that meeting. Okay, so now here's an interesting situation. Ammonium, what is that? Well, it is a polyatomic positive, a cation, NH4. So it turns out that it has, you could make a guess of what its charge is. Chlorine, there's only one of these, and chlorine, remember, is a group 17 halogen with a -1 charge always. And so that, by reasoning there, logic and reason would tell us that NH4, ammonium, must be a +1, and that's what it is. So there are more examples here. Beryllium nitrate, for example, NO3 is the polyatomic anion. Here's lead-4 chlorate, ClO3. Again, another example of a polyatomic anion with a charge. Okay, so as we get some practice this next week, you'll see how all that sort of comes together. Okay, all right, thank you for watching.